In this video, we're going to learn about more methods within the list type class. We'll be writing the method that allows us to search through the list. So far we've created in our list type class 3 of our goal methods. We created 2 different constructors, and that satisfied our goal to be able to create a new list object. We also wrote a method that allows us to store information into the list. That was our add method, and we wrote a method to retrieve information in the list. That was the get method. So now we're going to be turning our attention to a new method, something that allows us to search through the list to determine whether it contains a particular value. Remember that in the ArrayList class, there were different versions of a sequential search type algorithm. There was one called contains. It allowed us to search through a list to see if a value was contained in the list and return a true or false value. There was also an index of method that allowed you to search through the list and return the index of the first value in the list. We could write either of those to be part of our list class, and of course we could also write both of them. We're just going to write the one that works like contains. If you want to write the other one, you can do that on your own and try it out. So our goal is to look through the collection, try to find a particular key value, and then we want to return a true-false return value based on whether or not the object was found. So first think about, could this method throw an array index out of bounds exception? No, it can't, because we're going to write the search algorithm, and so we can make sure to control that it stays in bounds at all times. When we were writing the add method, we couldn't control when somebody was going to call that or how they might call it, like more times than there were spaces available in the list. Similarly, we couldn't control how somebody would call our get method. They might call the get method with an index that was out of bounds, and so we had to protect against that. But as we're searching through an array that already exists, we can control which items are accessed, and so we can make sure that we only access the actual data values that are part of the collection. So this particular method's not going to need to throw any exceptions. So let's think about it. Suppose that we are looking for a key value like 6. So sequentially searching through the list, we'd compare 6 to 1, no, 6 to 9, no, 6 to 8, no, 6 to 5, no, 6 to 6. Yes, we found it. So that's one potential outcome. We could be looking for a value and it might be found in the list. In that case, we want to return true. We could also be looking for a value that's not in the list, like 60. In that case, we'd want to compare 60 to 1, no, 60 to 9, no, 60 to 8, no, 60 to 5, no, 60 to 6, no, 60 to 2, no, 60 to 3, no, 60 to 4, no. And at this point, we know we're at the end of the collection. We've reached the actual size. So once we've reached that point, we don't have to search the other empty data values. So that'll be the end of our loop that we create within our sequential search class or sequential search method. So let's go ahead and write our method. It's going to be a public method, so we can call it from outside the class. We want to return a Boolean value, a true, false. We can call it contains, or we could call it search. It doesn't really matter, whatever you want to. And we want to pass in an object that's the key value that we're looking for. And now we just want to write our regular sequential search algorithm. We've written this lots of times. One of the important things to remember is that you can't know the items not found until you look at every single object in the array. There's a lot of people in 220 that have to fight against the temptation to say, like, I compared the key to the current value in the array and they don't match, so immediately I'm going to return false without looking at the rest of the list. And of course that sometimes makes you return the wrong value, because sometimes you're looking for a key that is actually in the list, it's just not at the first position. All right, so we want to write this contains method. We're going to set up a counter. Or you can call it index or whatever you want. And we want to keep going while count's less than the actual size. How many items are actually in the collection. Inside the loop, we want to compare to see if our key value equals the current list value, so that'll be array at index count. And if it does, we want to return true. And then we want to update the value of count so that we move to the next item in the collection. Oops. I feel like maybe I got extra parentheses in here. Oh, yep. All right, so that's the end of my while. And if I get down here after the while and I haven't returned true, then I want to return false. That means I haven't found it yet. If that's confusing to you to have one of the returns inside the loop and one of them outside the loop, you could also create a special separate variable Boolean result, set it equal to false, and then in here you'd say result equals true. And then down here you'd want to return result. That'll do exactly the same thing as what I coded before. The end of contains. So that's our whole method. Again, that's the sequential search algorithm. You always go through. It's a count controlled loop. You iterate once for each item in the collection. So you stop when you reach the actual size at the end of the collection. You want to compare the key value to the current item in the collection. So that's the array at index count. Here we know that our objects in the array are object data types, so they're reference data types. That's why we have to use the dot equals method instead of the two equality signs. And then we want to update the value of count at each iteration so that we're moving to the next item in our collection. If we ever find that the two values are equal, we set result to be true. If we've never executed that code, then result will still have its initial value false when we return at the end of the method. So we can add code to our main method to test this out. We could do something like system.out.println. Does my other list have a, does it contains the value 1? So in this example, that should print out a true. And then we could also test for something that's not in there, like other list dot contains. Does it have like a 66? So my program's going to print out my contents. Oops, maybe I didn't choose run. It's going to print out my contents of the array at 0 and 1. And then does it contain the value 1? That's true. And does it contain a 66? That's false. So it looks like our contains method is working in both cases. We have just a few more methods to go. Let me add in my comments here so I don't forget about them. Contains checks to see if the key value is in the list, and key is the item to search for, and it returns true if key is found and false otherwise. So now I got my documentation in there, and we've completed 4 out of our 7 methods that we set as our goal. We have 3 more methods to go.